Welcome to a lesson with Dr. Powell. Let's take a look at the tangent function and the cotangent function as pictured on the unit circle. Okay, so the sine and the cosine represent x and y coordinates. The tangent and the cotangent represent different things. The tangent represents the slope. So we'll start with tangent. It represents the slope of this line right here. It should be clear if we think of it as being sine over cosine or y over x. That's a slope, rise over run. Okay, so let's think about what the slopes would be in the first quadrant at the given special angles that we're working with. So we have 0, pi fourths, pi halves. Let's do pi 6. Let's do pi thirds. Okay, so right here, let's think about what the coordinates in x and y are for pi 6. Well, it's the smaller y value in the picture, so y value is 1/2, and the x value is the larger one, less than 1, so it would be square root of 3 over 2. Okay, so if you were to take a ratio of those two, so y over x, so the y is the 1/2, and the x is the square root of 3 over 2. Notice you have 1/2 on the top, and this is 1/2 times square root of 3 on the bottom. So the 1/2s cancel because they're factors at the top and bottom. So you're left with 1 over root 3 as the slope for pi 6. And that's also equal to the tangent at pi 6. Okay, so we'd get 1 over root 3 for that slope. This one should be pretty simple, pi fourths. That's just a slope of 1. What about pi thirds? Well, notice across this line, this is the line y equals x. And this is symmetric about the line that way. And when you're symmetric about the line y equals x, you actually switch your x and y values. So in other words, you get a reciprocal. This being y over x, now those switch places. So root 3 and 1 switch places. So this slope should be root 3. So you have 1 over root 3, 1, root 3, and then this one right here is undefined slope, or infinite slope, if you will. This slope right here is actually 0, right? 0 slope, 0 rise over any run. And you can also get this square root of 3 too if you just thought about the x's and y's. The x here is the smaller x, which is 1/2. The y is the bigger y, which is root 3 over 2. And 1/2 is a factor of the top and bottom would cancel. You would end up with square root of 3. Okay, so this kind of gives us a nice sense for how to think about tangent of the different angles. For instance, what if we had the tangent of 5 pi 6? So 5 pi 6 is pi 6 shy of getting all the way to pi. Okay, so by symmetry, we could think over here, this one is the smaller one, which has a slope of 1 over root 3. This is just the negative of that slope. If you look at it by symmetry, you just have a negative, you just changed your x to be a negative, it just changes the sign of the slope. So this would be negative 1 over root 3. So tangent of 5 pi 6 is negative 1 over root 3. Okay, now let's think about cotangent. What is cotangent? Cotangent is simply the reciprocal of tangent. Wait a minute, do you notice how we were taking reciprocals from here to here? We can also, from this part to this part, changing the angle. Well, if you don't change the angle, if you don't want to change the angle, you can just simply change the function. Hence, that's why they're actually called cotangent. It's because it's a companion of tangent. They're across here. by this reflection idea. Okay, so if we take, for instance, the cotangent of, and this time let's do 5 pi thirds and see what that would be. So 5 pi thirds is actually going to be down here. The larger of the y values, but then it's going to be negative, right? So it's down there. So it's going to be the negative of that slope. So negative root 3 is the slope. However, the cotangent we're going to think about as being the reciprocal, because notice when we reflect, notice what's happening. We're taking a reciprocal y over x, those switch places. So we're taking reciprocals across this line. Even 0 and undefined are reciprocals, if you will. So we find the tangent and just take its reciprocal to get cotangent. So the cotangent of 5 pi thirds is negative 1 over root 3. Similarly, let's look at another one. Let's look at the cotangent of 3 pi fourths. What's that? So 3 pi fourths is actually in this quadrant right here with a slope of negative 1. And the reciprocal of negative 1 is just negative 1. Thanks for watching.